Hello, everybody. Welcome to Webinar Wednesday. My name is Martin Loffers. I'm the Chief Trend Watcher of Supply Chain Media. You might also know me as the Editor-in-Chief of the European Supply Chain Quarterly called Supply Chain Movement. In the next hour, we have a great webinar. We'll talk about smart logistics and risk management. And we also talk about digital twins, a hot topic nowadays. And we will do this webinar together with PSI Logistics, the experts on this digital twin matter. So with me, I have, not in the same room, but in Germany, I have Cindy Schmidt, Sales Manager of PSI Logistics. Cindy, hi.
Hello, everyone. Thanks for having us here today.
Hello. And next to her, we have Tim Piotowski, Logistic Engineer of PSI Logistics. Hi, Tim.
Hi, Martin. Thanks for the warm introduction. Hello, everyone.
All right. Some household rules. This webinar will be recorded, and the PDF of the slides will be made available in the next 48 hours. We have decided to put the cameras off so you can enlarge your screen. Next to my small picture, you see 4 arrows. You can enlarge the screen and the presentation if you want to watch it closer. Next, we also have the opportunity to ask questions. We will have a Q&A at the end, but you can also ask questions right away. So basically, you will see different kind of functionality. You have the chat function. You can ask questions. Will this webinar be recorded? Yes, this kind of questions. But if you want to ask questions to Cindy or Tim, please use the Q&A functionality on the right-hand side. We do have a Q&A at the end, but if we have more questions, we will also have, after 5 o'clock CET, we have a half an hour, and we have a Q&A option in the lounge. So you can talk to Cindy and Tim and myself in the lounge, and we'll be seated at table 1. Basically, you will get a screen after 5 o'clock, and you will have the opportunity to talk with us in a kind of Zoom meeting, and you can have a further discussion about digital twins. All right. Okay, why this topic? Supply Chain Media did a survey last year, just after the first wave of the pandemic. We asked 106 manufacturing companies in Europe, all kinds of supply chain executives. We asked, what is the software you're going to invest in the next 12 months? And as you can see, well, you see all kinds of types of software. But I highlighted 3 of them. End-to-end supply chain visibility is the number 2. And if you look at the more mature companies on a level 4 or 5, according to the Gartner supply chain maturity level on 1 to 5, you see the more developed and mature companies are going to invest in end-to-end supply chain visibility. Also, supply chain network design is hot, especially among the more mature companies. And on the lower end, you see another spike, supply chain risk management. Cindy, what is your reflection? Do you recognize these kind of needs for supply chain software?
I actually come to the same conclusion. My feeling is the more complex a supply chain network is of a company, the more they want to invest into data quality, supply chain visibility. So to make really use of the data which is available in-house, they want to use it in a software system which is covering the buzzword supply chain network design. And of course, risk management is very difficult to take control of if the complexity of the supply chain is increasing continuously. So definitely reflects my experience.
All right. But Cindy, could you explain a bit more about your company, about PSI Logistics?
Sure. PSI Logistics is basically a software company that specializes in logistics applications. So to be a little bit more specific, we distribute for products which can be seen in the gray box on the bottom. So we do have software systems for the management of warehouses, transport, supply chain networks, or airport operations. And over the years, the company has grown to a turnover to 19 million euros in 2020 and more than 220 employees. As you introduced us, we are sitting, or our headquarters is sitting in Germany, but we have, of course, further sites in other countries such as Poland and Russia.
All right. The supply chain of today are a bit of a turmoil. It's a chaos, and there's a lot of vulnerability. Maybe you can explain more what you're seeing in that matter.
Sure, I guess as the audience knows, for the establishment of global supply chains, the complexity had necessarily to increase over the last couple of decades. And the resultant benefits are very well known, like lowest costs and short lead times. But our feeling at PSI is that this development comes, of course, with new challenges. And I have picked some of these challenges of the last years and displayed it on the slides. Of course, we do have the Brexit, the Corona pandemic, and the latest one, the blockage in the Suez Canal. And I guess the whole world is now realizing that we have three concomitants that seem to be present at all the time. So first of all, risks appear on a regular basis. Second, the geographical impact is very hard to evaluate. And third, the temporal duration is very hard to estimate. So all over, we can say the reality is sometimes unpredictable, which is why companies need now more and more methods to identify and classify risks early. So we all aim for preventive measures for the future risks and try to keep the damage as low as possible.
And I can imagine, a lot of people are asking me, when this whole turmoil in supply chain will be resolved. Do you have any ideas in that matter, or does it differ per industry?
I'd say there is not really a difference in the industries. I guess this is a hot topic for each company with a certain size. So I'd say it's really an all-over topic.
Yeah, right. There has been a survey done by GEP, and you have some interesting figures. Maybe you can explain the strategic aspects of supply chain management nowadays.
Yeah, I picked a study from Harvard Business Review. It's from this September, and it focuses on the transformation of supply chains for higher performance and resiliency. And let's just pay attention to the chart in the middle first. What we see are the top goals of the 276 respondents. As we can see, cost reductions have a clearly high rank, but its importance has decreased. To be a little bit more precise, we are talking about 50% in 2020, and it went down to 44% in 2021. And a similar trend can be seen at the improvement of productivities and efficiencies. But now, if we take a closer look, we see on the contrary that a majority believes that the strategic value of supply chain operations will grow in the year ahead. So therefore, the importance of business resiliency, business risks, and fast reactions to emerging supply disruptions increase. I really like the chart on the right side. We see that the companies are divided in three categories, which are leaders, followers, and laggards. And the business goals have basically remained the same. But what we see here is that the less mature a company is, the more it focuses on cost reduction. And that is pretty much fitting to the survey you showed us at the very beginning. So leading companies are striving to address risk management, resilience strategies, and environmental sustainability.
Yeah, and what we saw in our survey was that the less mature companies are still focusing on ERP system, so get their house in order, or sometimes warehouse management system. So basically, more order management level, they are still implementing stuff. And what you see then is in line of this survey, the more mature companies are looking more to risk management and resiliency.
Exactly.
So what kind of trends do you recognize in the world right now?
Yeah, there are lots of trends coming up right now, and I've picked an article from Supply Chain Brain. It summarizes the top 12 trends that shape the industry of this year. But honestly, while already skimming through the slide, we realize that these trends will be a hot topic in the next year as well. Mm-hmm. I was shortening down the list to 5 bullet points. And we believe at PSI that especially these buzzwords are associated with competitive advantages. And for us, digitalization plays the most important role because it can be seen as some kind of enabler for all the other trends. So we believe the data should not only be collected, but also intelligently used in, for instance, algorithms to act quickly in dynamic markets. And only in this way, historical data can make processes in supply chain management visible in order to improve, for instance, the other trends like resilience and redundancy in the network. And what I find quite interesting is that we observe the same approach very strongly with regard to sustainability. So many companies do not have right now the data to calculate their own carbon footprint as accurately as possible. And that could become in the next couple of years a problem due to political decisions, for instance.
And what I also see when I watch these trends, these trends are also strengthen each other. So redundancy and nearshoring, they go hand in hand, and also sustainability make your supply chain shorter. That will make your supply chains more sustainable or more carbon friendly, I would say. So the other four will also be going hand in hand. And as you said, digitalization is a good enabler to achieve all this.
Absolutely.
And risk management, we have discussed it already before in some other webinars, and we have written about it. But maybe it's good to see, okay, what are the dimensions of risk management?
Yeah, I did show some business goals and of course trends, and I guess we all know that in reality it's very difficult to meet these trends and business goals because there are many different dimensions we have to take into account within the field of supply chain management. And some of these dimensions are shown on this slide here. I just picked 4, which are supplier network, transportation, visibility, and production. And for each of these dimensions, I have raised common target questions asked by companies. So, for instance, what is the right balance between single and multiple sourcing, or which transport routes can be used alternatively in case of appearing risks, or how to quickly adjust production plans if demands in market shift. And I guess nowadays it's no longer sufficient anymore to focus on one dimension alone. Instead, companies require a holistic view that can only be established with the help of continuous risk management.
Yeah, and it's interesting to see that you have different kind of questions, but it's also good to point out that companies have to match the goals and the risk and translate them into practical senses in the supplier management and manufacturing, but then again also in a holistic way that everybody within a company should be aware of these translations of these goals and risks. And it's a good point you have made that it's not in a silo you can do this decision. You have to take back on a higher level to see how you can manage all this. So then we get to the question, how can these challenges be mastered?
Exactly, because I did not want to only present upcoming trends and issues coming with it, but also some kind of solutions. And we picked our software system PSIglobal for today. It is a software solution for strategic supply chain design. And what is basically happening is we import data sets like location, shipment, and item data, and the software system creates then a supply chain digital twin, which can be seen on the picture right here. So with this digital twin, we analyze and optimize existing logistics networks or one that is to be newly developed. And the software system comes, of course, with numerous functionalities which support the identification of inefficiencies or the continuous improvement of logistical structures. And this gives our users the opportunity to, for instance, determine the right number and geographic distribution of locations, or to optimize the flow of goods through the logistics network.
But this kind of system is not only to be used for considering a new warehouse, but you can also use for ongoing business, like last year with the COVID-19 crisis, to take decisions when things are changing in your network, isn't it?
Exactly. We use historical data, but also perhaps data which might be relevant in the future. And we're taking a bird's eye view on the whole supply chain to analyze and optimize the interrelationships that have been or will be in the future of different suppliers, productions, warehouses, and transport in between those locations, for instance.
So maybe you can explain how a digital twin will be built based on which data.
Yeah, so I was already mentioning some data sets, and we are taking this data from operational systems, which can be found in each company. So examples are ERP, WMS, TMS systems, or simple Excel files. And what now is happening is we gather all this information within the software system and create some kind of horizontal networking to get an overall picture, which is very necessary for a strategic orientation in the area of risk management.
And I get often the question, how long does it take to develop this kind of digital twin?
Yeah, I guess there we need to separate two categories. The first category is gathering all the information and data sets. This is usually part of the company. Who's which is purchasing our software, and this can take from days to weeks. It really depends, but to only create digital twin within the software system, this takes a few days, and to run scenarios, a couple minutes.
Great, and that's good to hear, because I think that one of the resolutions for companies to get out of this supply chain turmoil we are in right now is to use a digital twin to get a better picture of capacities in your network, in your end-to-end supply chain network, but also inventories, etc. And in that case, a digital twin can be very useful, or maybe quite necessary. Okay, next, thank you, Cindy. So we go over to Tim, because we will have also a demo case. So Tim, would you explain it first and then show it in real life, or would you explain it first?
Yeah, I will start to explain the initial situation on the slide, and I will then share my screen. So in this showcase, we look at a distribution network. Originally, there are 5 warehouse locations in this network, serving customers all over in Central Europe, and we would like to analyze the expected risk of a warehouse failure in this network. In particular, we will simulate the failure of the warehouse in Bad Hersfeld, and our task then is to analyze the impact of this warehouse failure on the network, how will costs and service will develop, and what are possible countermeasures to cope with this situation. So this is something we will do in the software, and we will see how a digital twin will support us during this process.
Yeah, and this kind of example is very applicable to what we have seen last year, and currently also with lockdowns. Factories had to be closed because of the corona pandemic.
Yeah, very good example.
All right. I would say, please share your screen, and then I'll take it away.
Yeah. So you should be able to see my screen in a moment.
Let's see. Yep, there it is. Yep, we can all see it. Yep.
Okay. So you can see the exact same baseline scenario we already saw on the slide. We have warehouse locations in several European countries, visualized as yellow circles on the map. We have customers in several of these European countries. A customer, for example, are these small gray dots on the map. You can see we have relations on the map representing the shipments between warehouse and customer locations. And in the background, you can see we have a kind of area coloring showing the service level reached in the baseline scenario here. So areas which are colored in green have a good or excellent service, and areas colored in yellow to orange have a service which is still acceptable, but maybe not sufficient enough for the purposes of this company or this distribution network. So we will now go on and start with analyzing a risk scenario or doing a risk assessment where the warehouse in Hersfeld will be closed. So I've prepared the map. So you can see the warehouse is no longer operational in this showcase, and our task now is to assess the impact on the network. So we will try to find possible strategies to cope with this situation. The first scenario we will look at is operating the distribution network with the remaining 4 warehouse locations. So we use the warehouse locations in Venlo, Freiburg, Paris, and Warsaw, to satisfy all customer demands. This, of course, only works if the warehouses have enough spare capacity or free capacity left, or if this capacity can be built up at short notice. So we will check this as well. And for these analysis, we use the location optimization function of PSIglobal. With this function, we can optimize the network structure, either in one-level or two-level networks. For this showcase, we just look at a one-level approach. We can do brownfield scenarios or calculate brownfield scenarios as well as greenfield scenarios and mixed forms. We start with a brownfield scenario in the beginning. So we just go with the warehouse locations which are currently on the map. So these 4 warehouse locations are used to supply all the customers on the map. So I have selected them as fixed warehouses here. These warehouses has to be opened by the algorithm. We calculate the best possible solution on the basis of transportation and warehousing costs. For the calculation of transportation costs, we do not use the direct distances. We have a digital road network in this software, which we can use to calculate the exact transport distance between each location on the map. So we use this realistic transportation distances. And in customer projects, we usually use customer-specific tariffs to calculate the transport costs. Obviously, in this showcase, we do not have such a tariff, so we go with a simple linear full truck tariff here, which we have for presentation purposes.
Tim, I have a question. If the borders are closed, can you also manage this in this environment?
There are ways to do this, but it's not the straightforward approach here. So I'm pretty confident that we can do this, but it takes some work to do this border closure, because usually this road network is connected to each other.
No, yeah, but last year there were some borders closed. That's why I'm asking.
Yeah, you're right. So there's no straightforward way, but I think, and I'm confident that we will find a way to simulate something like this if it's necessary for a customer.
Okay, cool.
Yeah, for the warehouse locations, we can take warehousing costs, for example, something like handling costs into account. For the purpose of this showcase, we made the estimation that the warehousing costs in Poland are 25% cheaper than in the Western European countries, just because we expect lower labor costs in Eastern European countries. And we also take the capacity constraints on the warehouses into account. So we will see whether the capacity of the warehouses is sufficient to cope with the failure of one warehouse. Yeah, I would suggest we start the optimization, and we will see that we get a result within seconds. So we can see each customer, which were originally assigned to a warehouse here in Bad Hersfeld, is now assigned to a new warehouse. And we see that some of the customers are, for example, this one, are assigned to 2 different warehouses. This indicates to me that at least one of these warehouses is at a capacity limit, but still we were able to satisfy our customer demands with this solution. We will have a look now on the impact of the service level. So this is pretty much the same analysis I did for the baseline scenario. You can see, again, we are talking in this case about driving time or travel time to the customer, so from the dedicated warehouse to the customer location. And I can select class boundaries which are appropriate for my or for the customer needs. So I've just defined that anything less than 5 hours is an excellent service, 5 to 10 hours is a good service, and anything beyond 12 hours is beginning to be problematic in this showcase. So we will see the impact of the warehouse closure on the map in a moment. So you can see, and maybe if you remember a little bit the area of the service level of the as-is scenario, you can see we have a small service decline in this area here. The service issue we already had in the southeastern part of the map is a little bit worse than before. So in the end, we can go with 4 warehouses, but issues with service might indicate that we have to look on a different solution here. Nevertheless, we will compare the costs of both scenarios. So you can see the bar on the left-hand side is representing the baseline scenario, and compared to the baseline scenario, the costs are rising moderately. This is perfectly explainable. This scenario on the right-hand side, we have only 4 warehouses, and with only 4 warehouses, we are in a sense further away from our customers. So the transport distances are rising, and with the transport distances, the costs or the transportation costs are rising as well. On the other hand,
Tim?
in this scenario, we only have 4 warehouses.
Tim, you have to share your screen again. Somehow it flipped off.
Somehow dropped. Okay. Sorry about that. I'm not sure whether it happened or how it happens.
No problem.
So maybe I will open the bars again. I'm not sure.
Yep.
Okay. So anyone get the point? Hopefully. We have slightly higher costs in this scenario for transportation. On the other hand, in this scenario, we only have to operate 4 warehouses. So in the end, this might be cost optimal, but we still have this service issue in this scenario. So we would like to look at a different scenario to cope with the warehouse failure. I will clean the map first, so we get the clear picture and not mixing up results from different scenarios. And in this scenario, we would like to find an additional warehouse. So a warehouse which is replacing the old one in Bad Hersfeld, but this time the optimization algorithm should decide which is the optimal location for this warehouse. So we are going with a mixed scenario from a greenfield and brownfield approach. So we keep the 4 warehouses we already have, and opening 1 additional warehouse. So I can select this number to my needs here. We're going with one additional warehouse from a candidates list. This candidates list is requested because we want to calculate on realistic transport distances. In this candidates list, we have for each 2-digit zip code area on the map, we have an area representative. So in the end, we get something like a target area. And in this target area, we will have a closer look for suitable warehouse locations. So we are going with a 2-step approach here. Yeah.
So this could be an existing warehouse from a logistics service provider, in a certain area you can include. Yeah. Okay.
For example, so we are optimizing right now only on transportation costs, because for this new or for this warehouse we would like to find, we do not know the handling costs so far. So we looking on which region is optimal on the basis of transportation costs, and then we will have a closer look in this area. And let's just start the optimization to see which is the best possible area to look at, and we will see that an optimal solution would be in the greater Vienna area. So from a transportation cost perspective, this would be the optimal place to be for this warehouse. So in a customer project, we would now approach a consultant for logistic real estates, for example, and ask him to find suitable locations within this area. So maybe warehouses which can be rented in or around Vienna, or suitable locations to build a new or entirely new warehouse. And as we are very close to the borders of Vienna, of Slovakia and Hungary, so Eastern European neighbor countries, we ask the consultant to find suitable locations in this country as well. So we expect lower labor costs here and lower warehousing costs, and we will see how this will impact the result or the final decision. The result of this could be something like this. So I've just searched 9 locations in around Vienna and in Hungary and Slovakia as well. So you can see 5 of the locations are in the greater Vienna area and 2 in Slovakia and Hungary. And the task now is to find for this suitable locations the best, or to choose the best out of these 9 suitable locations. So we are doing like something like a closer analysis of these candidates.
Tim, you have to share your screen again. Something okay. You know,
I'm not sure how this happens. Sorry about that.
No problem. You know, we can follow it. So you had 3 candidates in the Vienna area.
5 candidates in the Vienna area.
Sorry. Yeah.
And 2 in Slovakia and 2 in Hungary. So these red dots are appropriate locations for building up or renting or opening up a new warehouse location. And we use the same optimization again, just changing the candidates list. So the optimization algorithm can only choose one of these 9 warehouse locations. And I've activated the warehousing costs again. So we can see that we get the results on the basis of transportation and warehousing costs. And we can see that if we take both costs into account, we do not get the result in Vienna, but in Senica. So one possible solution to cope with the warehouse closure is to open up a new warehouse in this area. And we will see how this impacts the service. So I have the same service class analysis again. I will just perform it with the same class boundaries. So we can compare this to the other 2 scenarios, and you can see already on the map that we have made significant improvements to the service, especially in this area. So in the end, we found a solution which is solving a problem we already had in the network, the service issue in the southeastern part on the map. Again, we would like to compare the costs of this scenario, and you can see on the right-hand side, the bar is representing the scenario with the location in Senica, and you can see we can also improve or we can also save a lot of money or reducing the costs of this scenario for warehousing and transportation. So we found a solution which is not only cheaper, but also provides better service. So this is a very satisfying result so far. And another important topic nowadays is the sustainability. So Cindy and you, Martin, you talked about it a few moments ago. We can also use this software to calculate the carbon footprint or the CO2 emissions produced by the transportation in the network. So we use emission profiles like this to represent vehicles used for the transportation. I've only prepared one for the showcase, but in a customer project, we usually calculate with different vehicles or mixed vehicle fleets. So we can calculate again with fuel consumptions provided either by our customers or by internet service providers or something like this. So there are sources to get fuel consumptions for different vehicles. We can also calculate with emission factors provided either by the customer or by a D norm, which is included in the software. So we can calculate with the best possible assumptions to make very good results or very accurate results in these carbon footprint analysis. I have prepared a batch execution here, so I do not have to calculate this 3 times for each scenario that happens in the background right now. So each of the shipments in this scenario is now calculated with the exact carbon footprint. And I've prepared a chart for this, so we can compare the transportation emissions for each of the 3 scenarios. And we can see if we compare the baseline scenario on the left-hand side with the scenario with only 4 warehouse locations, that the CO2 emissions for transportation improve here. Again, keep in mind the transport distances are rising in this scenario. But in this scenario we just calculated with the warehouse and Senator, we were able to reduce the carbon footprint for transportation significantly, something around 25% compared to the baseline scenario. So this is a very good result. I've also prepared an area analysis for this. So each area is colored depending on the carbon footprint of the associated customers within these areas. So areas which are painted in yellow here have, or there are customers with a bigger carbon footprint, and areas with which are painted in green. In these areas, the customers are not producing so much CO2 emissions by transportation. So this gives us an overview over the carbon footprint of the network.
Well, that's quite interesting, because we will see the discussions in the near future about cost versus sustainability, about carbon footprint, and then you have a better understanding, a better feeling of how to make these kind of decisions and comparisons.
Exactly. So in the end, we found a solution, or we did a risk assessment. So we started on doing a risk assessment, but on the way we found a solution which is not only cheaper, but also provides better service and a lower carbon footprint. So this is something you might even think about if you do not have to close this location Bad Hersfeld. But maybe this is also a solution which can be implemented even if you do not have any risks in your network. So you found, by the way, a solution which is even better than the existing network you already have.
Yeah. And what you have right now, because of the computational power to do these algorithms and this optimization quite quickly, you can play with it to take out locations. Maybe it is happening, it might happen, but even you can check whether or not your supply chain network is robust enough for the future.
Yeah, exactly. You have a digital twin, and you can play around with it, or kind of play around with it. You can define different scenarios. You can look how your supply chain will react, how robust your supply chain is.
Yep.
Where do you have to build up redundancy, for example, where redundancy is not the solution for making your supply chain more resilient. So this is very useful for these purposes. Okay.
Yeah. All right. You can.
I will give you the screen again. And
yeah, I will go to my part. All right. So, Tim, thank you for this interesting and enlightening demo, live demo, I would say. So, Cindy, what kind of topics are addressed in this case?
Yeah, I get that you return to the slide we have seen before. We have seen that we could address 4 of the 5 listed trends, which to me emphasizes the importance of such software systems for the future. And Tim was already mentioning 2 other buzzwords, the redundancy and resilience. You can check within the software system. And we have seen clearly that with the scenario technique and with the short calculation times, we provide some kind of flexibility and agility for future decisions. So the whole comparison of results enables a very quick and strategic decision making.
And what I understand in our preparation, this case was built about a company in spare parts distribution, but I can say you can probably apply it to all kind of industries, this kind of business cases.
Exactly. We have used a spare part network in Europe, and it was just used to show how failures can be compensated and what flexibility is required. But I guess surely everybody in the audience can remember similar examples from their own experience in the last months and years.
Yeah. And we have also prepared a short second business case. Tim, could you relate to what you have created beforehand on the second business case?
Yeah, in this showcase, we are focusing on a production network. So in this case, we have several different production sites and warehouses, and we are not focusing on optimizing the network structure. So we keep the network structure as it is, but we are focusing on optimizing production plans and the material flow within the existing network. We would like to, again, analyze a risk which might be occur in the network, in this case, the failure of a production site. But before we can start with this, we have to flexibilize the production, because in the as-is scenario or in the existing production network we are looking at, we have kind of a single sourcing situation. So each item in this production network can only be produced in one location, and we have to change this first before we can focus on looking at different risk assessment scenarios, or at one risk assessment scenario, to be precise. So I will share my screen again, and we will look in this second short business case or showcase. I hope you'll be able to see my screen, and I hope it stays this way.
Yeah, we see it.
Okay, so as I already mentioned, we have different production sites visualized as blue squares on the map. We have warehouses in different European countries, visualized as yellow circles. And again, we have customers in several European countries. So in this case, we have a two-level network. So we have the first transportation level between production sites and warehouses. And from the warehouses, we have a second transportation level with the customer deliveries. So each customer is not supplied from the production site itself, but from a warehouse.
Okay.
The customers are demanding 5 different items, and we've chosen some very popular items maybe in the different countries where the production sites are located. So we are looking at the production of sangria, wine, cheese, chocolate, and beer. Each of these items, as I said, can be only produced at the beginning in one production site. So you can see in this table, for each item here, there's one dedicated production site at the beginning. So from a risk perspective, this is of course problematic, because if this production site will fail, we cannot produce this item any longer, and so the customer cannot be supplied with this item. For the production, we have production costs, and we also have capacities on the production sites. So each production site has a given capacity or an as-is capacity, which is usually used. And for emergency situations, we have extended capacities. Keep that in mind. We will use them later during the risk assessment scenario. We have the same setting for warehouses, so or not the exact same setting, because each item can be stored in each warehouse. So we do not have this dedicated warehouse per item here. So each warehouse can store all of the items. Again, we have different costs for storing these items, and we also have capacities. Okay, before we start with the risk assessment, we have to flexibilize the production. So we have to drop this strict separation of productions. For this purpose, I have prepared a different production characteristics table. Let me sort them by item maybe, and we look at the beer production, for example, right now the beer can be produced in each of the production sites, at least theoretically. We have different production costs per production site, and if we have to switch the production line, or if to modify the production lines in order to produce another item, then we have to pay setup costs for this. So in the end, we allow to produce each item on each location, and we will see how this will affect the production plans of the different production sites. For this purpose, we use another function of PSIglobal, the production optimization. First of all, we have to select whether we would like to work on a 2-level or on a 1-level network. As we have a 2-level network here, we select, of course, the 2-level approach. We have to define the locations. So we have to define which locations are production sites, which locations are warehouses, and which locations are customers. Again, we calculate with the realistic transport distances, and for each of the transportation levels, we have the opportunity to select a different tariff here. So in a customer project, again, we could choose different tariffs on different transportation levels. Here we use a simple intercompany tariff, which is a tariff we use for presentation purposes. This one is cheaper than the tariff on the customer distribution or customer delivery level. So this tariff is more expensive to reflect the differences in transportation costs on different transportation levels. Mm-hmm. I have to select the production costs and setup costs here. I also have to select the capacity constraints on production sites, and I have to do the same for the warehouses. So I have to select where the algorithm can find the warehousing costs, and I have to select which capacities should be used for the warehouses. And we will see, if I optimize this production network, that in this showcase, we do not see a big impact on the map, because in the end, each production site will still producing something, each warehouse will still store a lot of goods, and all the customers are still supplied. So the changes on the map won't be so significant here. We saw that the map has updated, but we will look and concentrate on the production plans to see the differences between the separated production here on top. And I open the production plan for the more flexible approach here. And we can see that we only have one change in this scenario here. So a part of the sangria production is now distributed to Belgium. So beside chocolate, the Belgium production site will also produce at least a portion of the sangria production. And we will see how this impacts the costs in this scenario. And we can see on the left-hand side, again, the baseline scenario, and on the right-hand side, the scenario we have just calculated. So we were able to save some money on the provisioning transports. At the same time, we have to pay setup costs for switching the production in Belgium. So in the end, we only get slightly cheaper in this scenario. But
yeah.
Go ahead.
No, it's not only a matter of cost, because I hear a lot of manufacturing companies want to be more flexible by creating more flexibility in their production lines. So this is also to present a business case to make your manufacturing more flexible, in this case for Belgium.
Yeah, and this flexibility is needed because right now we would like to assess the impact of the worst case, maybe in this production network, the failure of a production site. So we've chosen to close or to select the Spanish production site, and this production site will no longer be available in the next scenario, and we will see how this will impact the production plans and how it will impact the costs of the network. So the only thing I have to change here is to select a different location group where only the 4 other locations are enclosed as production sites. We can see we still have these as is capacities, and the first check we do is whether these capacities are suitable for the purpose or for the for compensating the missing production site. And we can see that it's not the case. So we only have 390,000 capacity units available here. However, to satisfy all demands, we would have to have roughly 17,000 units more. So one thing we can do, of course, is changing to these extended capacities. So some of the production sites might have to do some night shifts, for example, to compensate the failure of one production site, and we will see how this will impact the production plans. One thing we will see on the map right now is that this network, this production site in Spain, is no longer connected to the rest of the network. So in this case, we will see a slightly difference, and we will see how the costs will develop in this scenario. So as you can see, Spanish production site is not connected, and we will again compare the production plans. On top, we have the production plan we have calculated before, and we can see in the production plan on the bottom, the production site in Spain is no longer available. And this failure is compensated, or the sangria production is distributed to France and to Germany. So a part of the sangria production for the Southern European market is produced in France, and the rest is produced in Germany. And to enable this switch or this distribution, a part of the beer production has to be shifted to Belgium as well. So we will see how this impacts the costs. And yeah, it's not a big surprise that we get. Oh,
you have to share the screen. Yeah, sorry.
Yeah. But, I'm very sorry. I'm not sure what happens.
Doesn't matter. We can still follow your story, and it's interesting.
Okay.
Interesting to see how it works live.
Can you see it again?
Yep.
Perfect. Okay. So we can see that no big surprise. We're getting, or the network costs are rising in this example, but still we are able to satisfy all customer demands. Of course, we even save some money on provisioning transports, so we are producing more locally in this example or in this scenario. On the other hand, we have to pay a lot of setup costs. So the important message that should remain in this at this point is that you already have challenged your network. You have analyzed the risk of such a failure. You know the impact, and if the worst case happens, you are able to react much faster or even act rather than react, and you can rely on prepared strategies to cope with such situations. So this is something you always should keep in mind if you look at these risk assessment showcases.
Yeah, but and I especially like this because you can have a whole scenario book, I would say, to have assessed all the locations. What would happen if this location would be off the air, and what we should do next? So basically, you have a whole rule book what to do next if something could happen, and you already have assessed it beforehand.
Yeah, and this allows you to react much faster in the worst scenario.
Cool.
Okay, I will stop my screen sharing again.
No problem.
This time,
it went well.
You would like to stop it?
All right. So you can also do it on a larger scale, I guess.
Yes, exactly. On the screenshot, we have just integrated some ports in China and the US just to demonstrate that, of course, we can calculate diverse and worldwide scenarios. within PSIglobal. And I guess what we experience right now, that many companies are thinking to shift productions or different logistic activities back to Europe or to other countries because of upcoming risks in the future.
So what we also see right now, especially when the whole Congress in Glasgow is happening, with the focus on sustainability, that the priorities will change. Maybe you can relate to that, Cindy.
Yeah, exactly. For a very long time, the focus on supply chain management was on cost savings and service levels and maybe short lead times. But and for a very long time, these conventional solutions in risk management have been successful. But I guess now the situation has changed. We cannot deal anymore only with reactive behaviors to appearing challenges. Instead, we need really now intelligent software solutions, for instance, to cope with these dynamic changes, because we are within a fast-changing and worldwide market. And these alternative strategies and solutions are basically needed because inconspicuous criteria have gained weight. These are reliability, transparency, and sustainability. And let's just take a closer look to these priorities. A high reliability can be achieved by generating numerous digital scenarios as shown in Tim's showcases, and the various runs highlight basically and quantify the impact of unforeseen events. As the transparency aspect aims at the visualization and digitalization of the supply chain. So what we have seen is that the good data quality is for sure a must in the future. And lastly, again, the sustainability aspect. Like we talked about before, many companies are still working on the determination of the current carbon footprint within the logistics network, and therefore they do everything to gather the information about the goods production, transport routes, and vehicle fleet. So, and once they achieve this basis, the optimization potentials can be found to take adequate measures for the necessary emission reductions. So, intelligent supply chain network design supports, of course, companies step by step in achieving climate targets.
And where should companies start with all this?
So our companies help with in many cases with the gathering of information. So we need to ask about the vehicle fleet, about the transportation routes, and then afterwards we show them how to do these calculations within the software system where mathematical approach is embedded.
Okay, we only have a few minutes, 2 minutes to be exactly. So maybe a few questions. Afterwards, after 5 o'clock, we have still the opportunity to talk to Cindy and Tim in the lounge. So we get to that. But I got an interesting question from the audience. So Cindy or Tim, could you also apply this digital twin approach, what we have seen for reverse logistics, where to return certain goods?
I've just entered this in the text box or in the chat. Of course, we can use the function, the location allocation or location optimization function we saw in the first showcase to find the best possible warehouse or reverse point or reverse warehouse to optimize the material flow in the other direction as well.
Okay.
In the production optimization, this is not possible because this is focusing on the flow of goods from the production side to the customer. So the other function is capable to optimize this material flow as well.
Okay, thanks. Still, we have 1 minute, but we have to wrap up. So my suggestion would be to have a further conversation after this at 5 o'clock in the lounge. So basically, what the audience can do, feel free to join us at table 1. So Tim, Cindy, and myself will be joining you at table 1. And if you will click on a chair, you will be at table 1, and Zoom or MS Teams will open up, and you can talk directly to us. So next, for further information and reading, to the left, we have developed with some manufacturing companies an end-to-end supply chain self-assessment, especially for COVID-19. It's very useful. You can download this self-assessment, 90 questions, simple yes/no questions, and based on that, you can assess your white spots. And what you typically will see at the technical level, that's the area of capacity where you have the need of more visibility, and that's the area of the digital twin. You see that on the left side. And on the right-hand side, you will have the availability to read more about PSIglobal. And PSI has also a YouTube channel. So with this, I would like to thank Tim, especially for the live demo. Thank you very much, Tim.
Thank you. Thanks for having us.
And Cindy, thank you for your explanation about more describe on a managerial level how to deal with all this.
It's great to be here. Thanks.
And the audience, thank you for watching, and I hope you liked it. I liked to watch a live demo, especially with this new digital twin tooling, and great computational power, and to see how a digital twin actually works, because we have seen a lot about it in the newspapers, how to discuss it. Now we've seen it live. So thank you for watching. Maybe you can join me and Tim and Cindy right after this in a minute in the lounge. We'll be sitting over there and we can talk further. And if not, I hope to see you next week on the next webinar Wednesday. Thank you, and maybe I hope to see you later in the lounge. Thank you, and bye-bye.
Thanks.